Welcome back to the lab. In this experiment we'll be studying kinetics, which is the rate of reactions, and it's really important for a wide variety of disciplines. We will use two colorimetric reactions. The first, a cobalt complex that can be either green or red, and the second, the reaction between potassium persulfate and potassium iodide, which will go from clear to a colored solution. Let's get started. This experiment is split into two sections based on the reactions we're investigating. In part A, we look at the cobalt complex, and in part B, we look at a variant of the iodine clock reaction. Part A1, you'll first prepare your cobalt complex stock solutions, which includes a green and a red stock. In part A2, you'll determine which ratio of volumes of these two stock solutions it takes to produce a gray color. In part A3, you'll move on and determine whether concentration plays an effect on the rate of reaction. And in part A4, you'll determine whether temperature plays an effect on the rate of reaction. In part A1, we'll first prepare the green cobalt complex stock solution. Weigh approximately 0.5 grams of this solid cobalt complex using a benchtop balance into a conical flask and then dissolve in about 50 ml of DI water. It's important that you keep this reaction on an ice bath for the entire duration of the prac. An ice bath must consist of both solid ice and water to facilitate thermal contact. Then take about 10 ml of the green stock solution into a test tube and heat it over a hot water bath. Use a wooden peg to hold the test tube when heating. In order to access the hot water bath, the rings must first be removed. Because of the risk of burns from the hot rings or steam, use tongs to handle the rings and only remove as many as you need. In this case, one should be fine. Place the reaction into the hot water bath. It's better if the reaction does not touch the bottom or the heating elements. Allow it to heat on a boiling water bath for 5 minutes. After the required time, remove the reaction from heat. Inspect the color of the solution against a white tile, and then you'll need to keep this red stock solution along with the original green stock solution both in an ice bath for the remainder of the experiment. For part A2, using a 10 ml measuring cylinder, I've added 5.03 ml of a green stock solution to it. It's important to try and read any measurement as accurately as possible, so 2 decimal places when using graduated equipment like measuring cylinders or burettes. To this green stock, use a pipette to slowly add your red stock solution with mixing and monitor the color change. You will notice in your manual it says to swirl, but a measuring cylinder of this size does not mix well when doing so. Instead, you can use a second pipette to draw up and redispense the liquid to circulate and mix the stocks. What you're looking for is a color change from green to gray, or rather the complete absence of green. In part A3, we're going to investigate whether concentration has an effect on the rate of reaction. We will do that by observing the same reaction at 2 different concentrations. In the left test tube, the darker green solution is 2 milliliters of the green stock solution, and in the right, the lighter solution is 1 ml of green stock and 1 ml of deionized water. Place each into the same hot water bath, recording the temperature from the thermometer and measuring the time taken for each to turn gray, checking every few seconds. In part A4, in a test tube you'll take approximately 3 ml of green stock solution and measure the time taken for the reaction to turn gray in a hot water bath. If you see red, the reaction has already proceeded past the gray point and you should stop your timer. It's important when you come to the water baths that you realize the labels are only approximate and you need to measure the temperature from the provided thermometers. As before, remove as many rings as necessary. As soon as your reaction is in the hot water, start your timer and remove the reaction to quickly observe the color every 3 to 5 seconds. In part B, we're going to prepare 5 runs of the same reaction where we vary the volumes of our 3 main reactants according to this table. In order to dispense the chemicals accurately, you'll use a 5 ml, a 10 ml, and a 20 ml volumetric pipette, ensuring that you put the correct reagent in the correct location. I've prepared run 1 where I have my beaker A and my beaker B ready to go. And what I'm going to do when I start is to transfer the contents across between beakers, mixing 3 times completely, then set it down on a white tile and time the color change. So, when I'm ready to go, cross 1, 2, and 3, set it down, and time the color change. After analyzing the data collected in these experiments, hopefully you've gained some insight into how variables such as temperature or concentration can affect these reactions.